Arduino is an open-source physical computing platform based on a simple input-output board. Arduino can be used to develop standalone interactive objects. The Arduino philosophy is based on rapidly making designs, prototyping. In contrast to classic engineering, which aims to create a strict process for getting from A to B, the Arduino philosophy encourages getting lost on the way and finding C instead. The Arduino platform was inspired by James Dyson, who made 5,127 prototypes of his vacuum cleaner before he was satisfied that he'd got it right. Arduino is completely open source, both the hardware and software, and is based on the idea of physical computing. Physical computing involves the design of interactive objects that can communicate with humans using sensors and actuators. These sensors and actuators are controlled by a microcontroller. A microcomputer is a small computer on a single chip. Arduino is composed of two major parts: the Arduino board, which is the piece of hardware you work on when you build your objects, and the Arduino IDE, the piece of software you run on your computer. The IDE aims to create a sketch, a little computer program, that you upload to the Arduino board. The sketch is effectively the program that tells the board what to do. The IDE, Integrated Development Environment, is a program which runs on your computer. The IDE allows you to write sketches for the Arduino board in the processing language. When you press the Upload button in the IDE, the code that you have written is translated into the assembly language understood by the microcontroller. The programming cycle on Arduino involves the following steps: installing Arduino on your computer, plug your board into a USB port on your computer, write a sketch, upload the sketch to the board through the USB connection. The board executes the sketch that you wrote. The Verify button verifies that the code is correct. When the code compiles, the IDE translates the code into an executable program that can be run by the board. The upload to I/O sends the current sketch to the board, which will store it in its memory and eventually run it. Once the code is in the Arduino board, it will stay there until you put another sketch on it. The sketch will survive if the board is reset or turned off, a bit like the data on your computer's hard drive. From a programming standpoint, Arduino expects two functions to exist, one called setup and one called loop. Setup contains all the code that you want to execute once at the beginning of your program. Loop contains the core of your program, which is executed over and over again. Arduino is not like your regular computer. It cannot run multiple programs at the same time. Also, the single program running on Arduino cannot quit. Thus, when you power up the board, the code runs. When you want to stop, you just turn it off. Here is a brief description of the code. Any text beginning with // is ignored by Arduino. These lines are comments. Int means the variable LED is an integer number. Int LED equals 13 assigns a value of 13 to the integer variable LED. The void setup line tells Arduino that the next block of code will be called setup. The opening curly bracket indicates the beginning of a block of code. Pin mode, LED output, sets the digital pin LED as output. Pin mode tells Arduino how to configure a certain pin. Digital pins can be used either as input or output. In this case, we need an output pin to control our LED. Loop is where you specify the main behavior of your interactive device. It will be repeated over and over again until you switch the board off. Digital write LED high. Digital write is able to turn on or off any pen that has been configured as an output. Delay 1000 makes the processor do nothing for the amount of milliseconds that you pass as an argument. Digital write LED low. This instruction now turns off the LED that we previously turned on. This closing curly bracket marks end of the loop function. To sum up, this program does this. Turns pin 13 into an output just once at the beginning, enters a loop, switches on the LED connected to pin 13, waits for a second, switches off the LED connected to pin 13, waits for a second, goes back to beginning of the loop.